everyone, and welcome to WOW 11 Day 3. This webinar, Model of Predictive Analytics, presented by Limuel, Sagadraca, and Amitabh Khosla, is brought to you as part of Mobius Connect's Week of Webinar series. My name is Alexa Gruber, and I'm the media specialist for Mobius Connect, and I'll be your moderator for today's session. Just one quick note before we begin, this webinar is being recorded, and later you will be emailed a link with access to the on-demand version of this webinar. And if anyone has any questions throughout this webinar, please feel free to leave them in the Q&A panel listed on your screen. At the end of this session, Limuel and Amitabh will be more than happy to answer your questions. And if for some reason we run out of time, we will send them your questions later for them to answer. Now, without further ado, I'm going to go ahead the presentation over to Limuel and Amitabh.
Thank you, Alexa. Good afternoon, everyone. I'm for attending our session on Model of Predictive Analytics. In the next 45 minutes, we hope to give you insights on maintenance strategies and tools to optimize or enhance your asset reliability programs. I am Limuel Sagadraca. My professional background is both an end user and as a consultant. I've been in manufacturing industry for over 30 years. My professional experiences revolved around operation excellence and leveraging technology in manufacturing at multiple industries. Throughout my career, I always concentrated on optimizing operations with a focus on people, process, and technology. Hopefully, our session will give you a little bit more of the insights of the different manufacturing strategies or maintenance strategies and some of the technologies that are out there in predictive analytics. Just to introduce our company just a little bit, Lifecycle Engineering was founded in 1976 and is an employee-owned company. The company's headquarters is in Charleston, North Carolina, with 10 offices around the U.S., with approximately 600 employees. We do have a global delivery. Our commercial business consists of three specific areas. First is intellectual property, or IP, what we call it, where we provide reliability tools and collaterals. The second is the institute, where we provide public and private classes. Yes? Private classes to achieve certification and continuing education. Last but not least is the consulting and services, where we provide maintenance planning, scheduling, and the Industry 4.0 practice. At this time, I will pass on to Amitabh for his introduction.
Good afternoon, good day, everybody. My name is Amitabh Khosla. I am the Chief Revenue Officer at a company called Shoreline IoT. We are an asset performance management software as a subscription provider. My background is in operations and maintenance. I started my career way back in petrochemicals industry, mostly as a machinery engineer. I spent a couple of years there, and then I started selling services in the domain of asset management. I have done that for around 25 years. I have worked for companies like General Electric and Honeywell, and that's where I learned a lot about not only asset management, but optimization of production processes and solutions that involve workforce competency. So today, I would like to talk about, along with Lemuel, how our users, you, our customers, and other subscribers of this program are going to benefit from our experience in asset management. What do you look for in a program, and how some of the modern programs are meeting some of the customer challenges? So that's what we'll be talking about. The next slide, please. Lemuel, could you move to the next slide, please?
I have.
Oh, okay. On the screen, it is still showing the first slide, which is my intro slide. Maybe it takes a little bit of time. Anyway, so let me talk a little bit about Shoreline IoT, the company that I'm the Chief Revenue Officer for. Shoreline IoT as a company was founded in 2019. Let me take a look at what's showing on. Yeah, so For some reason, it's still showing the older slide.
Hmm. Which slide are you showing, Amitabh?
I'm still seeing the slide with my picture.
Yeah, I'm currently on Shoreline,
Okay,
unfortunately.
okay, good, 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 good. So Shoreline IoT was founded in 2019 in California. It's one of the most modern asset performance management solutions provider. During the day to day, during this particular session, we'll be talking about how we are doing some things that are technically different and more beneficial to our customers. The company, for the first 1.5 year or so, we were primarily building machine models and the program for our cloud application. And then we have been commercial for almost last 12 to 18 months now. During the first few months, we focused on some very large customers. These customers are companies like P66, DCP, General Electric. In some of their appliance manufacturing plants, they're using our technology. Mitsubishi. Um, yeah, I think Limuel, for some reason, the PowerPoint isn't playing. So
Hmm.
if you could kindly email it to Alexa, she might be able to run it from
Yes,
her end.
maybe if you can, I just sent you a message, Limuel. If you could maybe email it to me and I
Okay.
can run it from here. I'm not sure. Oh, there it looks like it's moving now.
Now I actually see the new slide. Yeah, so thank
Mhm.
you.
Which
So
which slide?
you are
Let me
showing the
see.
Shoreline slide now, the Shoreline company introduction slide.
Mhm.
Thank you.
Hmm.
But in the meantime, if you can email her, she might be able to take over the
Just in
next
case
few
for a
slides.
backup.
Okay.
So the company is in providing a subscription-based software application for asset performance management. We are fully cloud resident, tested for security and access control by AWS. Many of these oil and gas customers, as they are very concerned about safety and security of their data, one of the ways we differentiate is we provide a very easy to adapt, easy to scale asset performance management program. And we'll discuss some of these aspects about how they are important to you as a user of asset performance management. So, with that, Limuel, I give it back to you, and you can go to the discussion about LCE, please.
Can you see the screen? What are maintenance strategies? I want to make
Yes.
sure you.
I'm
Okay,
seeing the
good.
correct slide. Yes.
Good. As you may all know, there are three maintenance strategies that most companies are using today. You can add a fourth for advanced controls, but in my experience, it is hardly considered given the state of the operations in most industrial companies. So, focusing on the three strategies, they are reactive, preventive, and predictive. Reactive maintenance is done upon failure, which means there's no maintenance on an asset during runtime. So upon failure, it is either replace or try to fix at the time of failure. This may be a good for some assets, but it is predicated on business needs. Predictive maintenance, on the other hand, begins to go away from being reactive and entering the realm of being proactive by using asset specifications to determine maintenance schedules. Some specifications one may use could be time and amount of cycles. An example where these are used is on car maintenance. With today's computer aided vehicles, one can get a service message when reaching a certain amount of miles. For example, at 25,000 miles, service A may pop up to indicate or to warn to change the fluids. And at 50,000 miles, service B may pop up to indicate change all the fluids plus parts of the powertrain due to wear and tear. The maintenance is predetermined by the specifications of each fluids and parts of the powertrain. Preventive maintenance program can minimize the amount of asset downtime with the hope that the asset does not break down prior to the designated specification. Unfortunately, oftentimes during the preventive maintenance schedule, using the car example, I may have been doing maintenance unnecessarily, whether it is needed or not. The third is predictive maintenance. Predictive maintenance gets into true proactive maintenance using analytics to determine asset health and projected time to failure. What does this mean to your maintenance schedule? It means only doing maintenance when it is necessary. Going back to our car example, It takes into account other factors. For example, depending on my driving habits and conditions, the fluids and or parts may be failing earlier or have a longer useful life than these specifications have designated. By knowing the asset health and time to failure, you may not need to do maintenance and extend the available time of an asset before maintenance is due. The fourth I mentioned is prescriptive analytics, which we will not touch on today. But if you have any questions separate from this session, please feel free to reach out to us. So as we dig a little bit more into these three maintenance strategies, these are listed as some of the disadvantages of reactive maintenance or run-to-fail strategy. I will pick on the first three for our discussion. Increased expenses. Adhering to a maintenance schedule oftentimes will prolong the life of an asset and is often less costly than replacing an asset due to catastrophic failure. Taking the car example again, following a maintenance schedule with the oil change will keep the engine running smoothly, which oftentimes will prolong the life of the engine. We often hear about engines lasting over 200 miles, 200,000 miles, I should say, when oil changes are done religiously without fail. Now, the rest of the car may be suspect, but the engine still keeps on rocking. Take the other extreme example without oil changes. The engine will not have optimal performance due to friction of the engine, internal parts, and mechanisms, which often will lead to catastrophic engine failure, which in turn need to be replaced, which is very costly. It has lowered productivity, is the second thing to consider. Downtime or low equipment availability can cause you to lose production time, therefore losing time to make products, which is money for the corporation. Another way to look at lowered productivity is from the people perspective. Too much equipment downtime or loss of production during normal operating hours may cause underproduction. Therefore, this could mean higher costs due to overtime needs to keep up with the demand. The third is higher unpredictability. Because of the unpredictable nature of a run to fail strategy, you'll need additional parts of complete assets to use when a failure occurs. This also has an effect on your warehouse footprint. It will stretch the footprint due to the needed parts and the assets to keep in inventory because there's no sense of when an asset failure will occur. An advantage, though, of run to fail to consider is running the asset full bore to a set amount of time or even seasonal production situations, then fully replacing the asset. This may be a good strategy if having any interruption in production time for general maintenance may cost more due to product loss than completely replacing the asset at the end of the season or time. As we get into preventive maintenance or scheduled maintenance, some of the advantages also applies to predictive maintenance, which I consider as the next level of maintenance. For our discussion, I will speak on a few advantages. Longer asset life due to keeping the asset at optimal performance. Fewer interruptions to critical operations since you can schedule around planned maintenance and have time to consider workarounds. Third is improve efficiency. Relates to the first. Assets performing at optimal performance uses less energy consumption and works more efficiently. But there are also disadvantages, of course. Need to invest on people. So your decision is whether the cost of people outweighs the cost of lost production. The other is over maintenance means that since the maintenance schedule is set to asset specifications, maintenance may not be needed at the time of the scheduled time. This happens because time or spec-based maintenance does not necessarily consider any operating conditions. Last but not least, predictive maintenance, which is truly your proactive maintenance. This strategy has the advantages of preventive maintenance, but addresses some of the disadvantages. Some of the advantages are the following: increased equipment uptime. By predicting when potential issues will occur, maintenance can be performed when it is most ideal for operations, preventing unnecessary downtime. There is cost savings, reduces the need for reactive repairs, and minimizing the amount of maintenance helps lower maintenance costs and increase overall productivity. It extends the life of the equipment, identifies potential problems early, and identifying possible time of failure as are key indicators to prevent maintenance for preventive maintenance. If you know a certain parameter is beginning to perform inadequately and know the possible time of failure, you can determine the time of performing the maintenance before a failure occurs. With regular monitoring and maintenance, equipment is kept at optimal and its lifespan is extended. Predictive maintenance involves hardware and software to make this happen. So therefore, I will pass on the baton to Amitabh for a show and tell of the technology that addresses predictive maintenance. Thank you.
Thank you, Limuel. So, when we look at predictive maintenance, like Limuel was talking about advantages and disadvantages, and when customers and users begin to deploy predictive maintenance, they run into some challenges. And I'm going to talk about challenges, and then I'm going to discuss how we resolve those challenges. How do we deal with those challenges with modern technology? The very first challenge that customers face is that when it comes to deploying technology for doing predictive maintenance, they obviously base that decision based on criticality. When you look at the entire industrial install base today, you will observe that around 10-15% of the machinery installed in customers' manufacturing facilities is monitored online. Customers are getting good quality data about those machines and they can take proactive decisions. But the wide variety, around 85 to 90% of those machines, which are considered either essential or balance of plant, they are currently not being monitored. And why do customers don't monitor that? Because they are either very expensive to install monitoring systems, or they're basically running some kind of a portable route-based manual inspection program. So that's one challenge that our customers face is how do I acquire inexpensive to buy and easy to scale asset condition and asset health management programs for my balance of plant equipment assets that I'm currently not monitoring. The second challenge that customers face is even when they decide to deploy technology, when they buy the toolbox and the tools that they use, it's very expensive to install them. It's quite cumbersome. And some of the challenges they run into are related to networking, security, data protocols, interfacing, system integration, and it just makes the whole task of balance of plant asset management very complex, especially in a running plant. You don't have a lot of time and money to pull wires and run power supplies and do all of this in a very infrastructure heavy way. So most customers today want an asset management predictive maintenance program that is somewhat as investment light, easy to buy, easy to install, and easy to sustain, easier to scale. That's what our customers are looking for. Go to the next slide, please. Thank you, Limuel. The second challenge that most of our customers face, is of in the domain of system complexity. So when you have when you have acquired a system management program, does it require a lot of capex upfront? Do you need to put in a lot of money to buy sensors and wires and power supplies and routers and data acquisition servers that can all become very capital intensive? Most customers desire that they should be able to start small and scale rapidly. Many customers expect that the hardware installation should be simpler. It should not require thousands of dollars to be spent on service engineers to be brought to site and them having to install these systems. Customers want networking not to be a problem. They don't want to deal with all of the IT security issues, and they would like to have a program that is not intrusive to their plant's network security, that can work outside the network security threats that they may face. And one of the concerns that many customers have expressed to us is when they buy programs that are primarily focused on wireless condition monitoring and inexpensive and cheap sensors. They believe that the adequacy of data and the adequacy of analytics is not enough. They can't really base their proactive and predictive maintenance decisions based on how much data is provided. So how do modern companies like Shoreline deal with that? And that's what I explain on the right hand side of the slide. We build a cloud-based infrastructure. In this infrastructure, we build physics-based models. These models actually reduce your time to value, how you gain value from the platform. And I will explain that a little bit more in detail in the next slide. Um, on top of that, we put some, go back to the previous slide, please. On top of the physics-based models, Limuel, go back to the previous slide, please.
Again?
Is the screen still being stuck?
Okay, let me see what I can do again.
So on top of the physics models, thank you, Lemuel. On top of the physics models, we build artificial intelligence and machine learning capability that can help us refine these models over a period of time. So as we learn from the customer's experience of using asset management, the system begins to learn from you and learn from us about how we deal with the data that's coming in. And the alerts, alarms, and actions that we deliver are very simple. They are in very plain English, so they can be easily understood by the operators and maintenance personnel in your plant. But what's most important is how we make it infrastructure light. We do two things for that. One, our sensor is non-intrusive to your plant network security. Our sensor actually directly communicates to the IoT cloud using one of the most modern cloud protocols called NB-IoT, narrowband IoT. It basically leverages the LTE infrastructure that most of the mobile phone companies have put together. This is specifically reserved for IoT. It is not the same band that you use for communication or downloading YouTube videos. This is a specific band reserved for IoT devices. So we make this device talk directly to our cloud environment without you having to buy any data acquisition infrastructure at site. The other way we remove this challenge of being capital intensive is that we don't need you to buy the sensors. You basically sign up the APM program and now you can subscribe to the sensors. The sensors are given to you for free during the life of the subscription. In addition to that, the system integration challenge that most customers struggle with, we have tried to make it very easy by making cloud applications or what is called cloud APIs, which are the interfaces that are pre-built for majority of the CMMS programs, computer-based maintenance programs, and also for plant historians and SCADA or DCS data. So if your data is in a cloud environment already, we can ingest it very simply, very easily into our database, and then we can start performing analytics on that. Last but not the least, the interface to CMMS. Why do customers need that? They need that when you get an alarm or an alert, we can actually trigger a work request directly into your CMMS. Limuel, now we can go to the next slide, please. So I wanted to explain the importance of why, how we are making it easier to use an intelligent asset-based management program. So the customers' challenges that we have heard about is that when they want to do AI or machine learning-based programs, they run into this challenge that these programs don't have any intrinsic knowledge or experience about the machinery or the assets. So these programs have to learn with historical database or with real-time database, which means it can take 3, 4, 5, 6 months for artificial intelligence programs to become knowledgeable about your plant assets or about your plant operations. What we do instead is we use physics-based models. These physics-based models already have characteristics of hundreds of different plant machinery equipment and also static equipment that we have pre-configured into our database. So we took around 2 years to build this knowledge base. This knowledge base allows us to recognize the data that is coming from the field and automatically start detecting anomalies without having to train the AI with historical or real-time data. This also enables our customers to start getting value from the asset management program deployment from day one. In fact, the sensors get deployed in 10 minutes. You start getting the data in the cloud within 15 to 20 minutes, and you start to get advisories back from us right from day one. So, as soon as you have deployed the asset management program, you start getting alerts and anomalies, and actionable advisory about how you deal with your asset management challenges corresponding to the machines that we are connected to. So, very easy to deploy, extremely easy to scale. And that's what you need to look for. When you look for an asset management program, look for those three aspects. Number one, don't buy an asset management program that is capex intensive on the front end. You're investing millions of dollars on the front end and then waiting for years to get value. Look for a program that starts delivering value from day one. Number two, it should be easy to deploy. Number three, it should be even easier to scale. So when you want to add more assets, you should be able to do that without having to spend capex, without having to spend extensive amount of time and money. Next slide, please. I just wanted to talk a little bit about some use case, an example of how a customer of ours started the program with merely 100 sensors. Their first order was 100 sensors, and they deployed it in two or three different plants. And then within a period of around 6 months, they now have a program that includes about 1,000 measurement points uh, across around 100 machines spread over 25 different gas gathering and production facilities. This is a midstream NGL company, and they have been working with us for around 8 months now, and they have benefited tremendously. They have made public statements. If you desire, I can actually send you the copies of the press releases that they have made about how they have benefited from this program, and they have been very excited how they are leveraging this technology. We can go to the next slide. I want to discuss specifically the value that they have. Limuel, next slide, please. So, while the slide is ready to change, this particular, okay, thank you, Lemuel. So the before situation, when you look at the problem that they were trying to solve, their challenge was a lot of their data acquisition was manual. They had to put people in a truck with a portable data collector, go from plant to plant to plant to acquire data from these very complex, not so easy to access machines. It took them around 30 minutes to acquire data from all the measurement points, and that data was not truly synchronized because while they were measuring one or two points, they were not measuring all the other points. So data quality was a challenge. The time and money that it took to get the data was always a challenge. The second big challenge they had is that even though they were acquiring this data, their program was still primarily reactive, and they had many machine failures that would slip through between the two data collection rounds. So if they were going there every month, sometimes the failure would happen between those two data collection intervals. And the current situation, or what is called the after scenario, is that they have deployed this program on around 100 machines, roughly 1,000 sensors deployed on these machine trains, and they are quite satisfied with how they have been able to become more proactive with their overall asset management approach. I will focus on the results at the bottom. At the bottom of the slide, they talk about how they have improved availability by 7% of these machinery assets. The throughput or the gas that they are pushing through their system has gone up by 12% because of that availability gain. And overall, they have a reduction of failures by 30 catastrophic stoppages. So if they were having 70 or 80 unplanned stoppages across their entire fleet in an year, now they are having 30 less. So we asked them, how much does it mean in terms of money? And they were not very specific, but they said an average interruption in process could cost them anywhere from 100 to $250,000. So if they are saving 30, even if we said it's an average of say $300,000 per outage, or maybe $200,000 per outage, that's roughly $6 million worth of benefit from 1 year by deploying this technology. And obviously, that's multiple times more than the amount of money that they have spent on this subscription based asset management program. They didn't have to buy any capital equipment. There were no network routers, there were no wireless data acquisition devices, just the blue sensor that you see on those machines communicating directly to the IoT cloud. Next slide, please. So, how does it do that? You look at what you are seeing in the dashboard. The dashboard tells me, as a plant engineer, how many assets am I monitoring? How are they doing from a health point of view? So, my top portion of the dashboard is dedicated to health, which is primarily condition monitoring. And the bottom portion of my dashboard is dedicated to performance, which is how am I doing vis-a-vis getting my energy balance between the engines that are running these compressors and the efficiency that I'm getting back from the compressors. So doing condition and performance management all in one platform, being able to see alerts and anomalies for any one of those health situations. Right in the middle, you see the alarms being flagged with red, yellow, orange colors, telling you what criticality you have. And then you can set up your own dashboards to monitor site-based criticality or site-based reliability score. And you can also build your own analytic view windows. These are widgets that you populate on your own dashboard. Very flexible approach towards asset management. An example of an incident would look like the next slide. If you can please go to the next slide. So the customer basically receives an alarm from us in their email inbox. Uh, Limuel, whenever you can, kindly flip to the next slide. Hello, Limuel.
Can you hear me?
Yes, I would request that you go to the next slide, please.
Yeah.
Slide 15. Yeah. Okay, this is okay. Let's be there. I wanted
Okay.
to let's go there. Yeah, let's skip that slide 15 for now, in the interest of time. So what this slide is showing you is how an intelligent alert is delivered to the customer. What do you want to see in an alarm management program? What you don't want to see is somebody just telling you, hey, you have a high vibration, go shut that machine down. That's not what you want to hear as a user. What you want to hear is, what is the problem, what are the symptoms of the problem, what is the root cause, where might be the problem coming from, what's causing this behavior, what's causing the performance upset. And then you want to get some recommendations. So we have SMEs that are machinery O&M experts, operations and maintenance experts. They look at the information that we are getting from the platform, and we have already incorporated standard operating process based advisories. If this is the fault type, if this is the level of severity, whether it's high or critical, these are the actions that you need to take. So we provide you the three pieces of information, which is the description of the anomaly in plain, easy to understand language. Then we provide you what's the root cause. Then we provide you what actions do you take. And then also you can see how many of which kind of alarms do I have. So you have an alarm dashboard. You can acknowledge the alarms. When you acknowledge, you provide feedback to the system, and the system automatically learns from your feedback. So any English language feedback you provide to the system learns from that and makes the machine models more efficient. Vimal, if you can get a sneak peek of the previous slide, that'll be great. Yes, thank you. So what you also see on this slide is the detailed data. So one of these things that many customers have complained about is, hey, I bought this program, but I don't get access to the detailed data. I want to see the diagnostic data. So we make the diagnostic data available. And then what you see at the very bottom is the customer endorsement feedback to us saying, yeah, you provided me good information. I was able to act quickly and resolve a problem without having to face a catastrophic unplanned failure in my plant. Lemuel, we can now go to the last slide. Thank you, sir. So, Lemuel, do you want to talk about this or may I?
I can start. In order to be successful in your predictive analytics for maintenance, you have to consider putting the correct foundation of your people, process, and technology. Oftentimes, technology follows the people and process, but I ask all of you to think about having the technology in parallel to working on people and process. This will create the buy-in with the end users, and the technology will help sustain the gains of your maintenance programs and initiatives. It is not easy, it is a journey. Amitabh and I talk about some of the services that we provide from an LCE and shoreline perspective, where we do understand that oftentimes companies do not have the resources that are that can go through the data at some point, but we have those service models for you to to consider. Amitabh?
What I would like to add to what you said, Limuel, is a very important aspect of your own selection process as users. So, if you are a customer or you're going to be a user of an online, modern IoT based asset management program, you want to work with organizations that can support all aspects of your process change as you define your steps to go from run to failure or PM dominated maintenance program to more predictive, proactive, and prescriptive maintenance program. As you make that journey, you want to work with companies that can consult and advise you on how you manage the process change, how you implement the changes in your own internal methodology. Most important aspect of that is how do you get your people on board? How do you train them adequately so they can adopt the program? How do you begin with some change leaders and then train some change facilitators in your business and then have more and more people join in adapting the new approach towards predictive, proactive, or even prescriptive maintenance methodologies. Technology alone doesn't get you from point A to point B. But when you're selecting technology, think about these aspects. Low cost to deploy, especially for startup and pilot programs. You don't want to be burdened with a humongous capital expenditure budget. You want to start with a low cost investment, start with a program that doesn't require any capital investment. Get the program up and running, and then once it begins to demonstrate results and value, then you scale and expand. And as you do this step by step, you also get better response from your people because they have time to accept and adopt this change. So as users and buyers of asset management programs, kindly be very considerate that when you're looking at embarking on this journey of change, make sure you have addressed these three very important aspects: the people that have to buy into the program, the processes and methodologies in your plant that must support the new program, and the technology that you buy has to be very carefully selected. Unfortunately, in the asset management domain, there are too many stories about people making false starts and not being able to become successful. So, if you keep this criteria in your mind, both Limuel and I will be happy to consult further and advise you in how you implement the selection criteria of who you choose to work with in the long run. Thanks for the opportunity to speak with you today. Uh,
Good.
we can go to Q&A now at this point in time, Alexa.
Yeah, I would just like to add, Amitabh and I hope we provided some insights for everyone to consider and use to achieve further success in your smart manufacturing initiatives, particularly revolving around your maintenance programs. So thank you for attending our session. We will now get into our Q&A.
Yes, perfect. Just like Limuel and Amitabh said, we are in our Q&A session now. So if anyone has any more questions, please enter them into the Q&A panel now. But we do have a few questions that did come in during this session. So the first one being, how early were you able to detect failures within days? Was there enough time to respond for the maintenance team?
Let me answer that, Lemuel, because it's a technology-oriented question. Um, so, because of the design of our asset management program, an average sensor deployment takes around 10 minutes. We start collecting data the same day. And actually, by the time our customers show up into the work facility next morning, right at around 7 or 8 a.m. in the morning. We can program all of that. We can configure that in the software. Most customers want that before they have their maintenance planning meeting in their office, they should be able to get the intelligent advisories from our platform. So within a matter of hours, we are able to take the data coming from the machinery assets. If we can integrate process data even better, and then we can start telling them very quickly what anomalies we are observing, what is the level of severity, and what corrective actions they have to take. So, unlike many other asset management programs that can take months to deploy, that can take months to train the artificial intelligence, we start delivering value from day one, if not day zero.
Yeah, let me just add to that, Amitabh. One thing that Amitabh pointed out that is very critical in any APM program is they also take in process data, not just asset data, because as I explained in some in the car example is unless you know the operating conditions and some of those process parameters, it could change the dynamics on when failures will occur. By adding process data, it will help enhance some of the predictive nature of asset failure.
Yes, absolutely. Machinery behavior very much so depends on the process conditions. So being able to correlate both of them together in the same time horizon on the same time platform is tremendously valuable. Thank you, Limuel.
Mhm.
Alrighty, thank you for answering that question. Another one, in installations with poor cellular coverage, do you have a cellular booster or repeater for customers?
That is a very good question. So we have had instances where the customers were deploying our devices on underground locations. These were factories, typically manufacturing plants, car making plants, appliance manufacturing plants, where they had to go underground. So when they went one level below the ground level, the cellular connectivity was not so great. So in those circumstances, we were able to put a booster on the floor in which the machinery was installed, and we were able to run a wire just outside the building. One booster was adequate for the entire factory floor. Our signal booster methodology is not about data acquisition. It's about just boosting the availability of the LTE signal. So please don't consider this as if it is that you are requiring more Wi-Fi routers, because many of these routers have a limitation of how many devices they can talk to at one point in time. When we install a booster, one booster is enough for the entire factory floor, and that was only required in those locations where customers went underground. Please be aware, this is something that you can look through in Google and download the data. The NB-IoT protocol, or what is called narrowband IoT protocol, even though it is an LTE cellular based service, it has 7 times the range of a typical GSM 4G or 5G service. So, what you have on your cellular phone is either 4G or 5G, depending on where you live. The LTE connectivity goes 7 to 8 times longer in terms of its distance range. So when we install our systems in gas fields, in the desert, in New Mexico, most people were not able to make a call with their cell phone, but they were able to send the data to our IoT cloud.
Yeah, let me add an experience that I had just to expand it a little bit. We had a customer where they tried other technologies and they were not able to get any type of connectivity. So they got into different routers and boosters and so on. But when we talked about this particular technology that Shoreline have provided, we went back to those certain areas where they did not get connectivity, and we were able to connect adequately. Now, in some areas where I looked at my cell phone service, it was at zero. But with the Shoreline LTE connectivity, we were able to connect anyway. So,
One
so,
of
uh,
the one of the
so,
other
so what I would recommend is since it's easy to install and you can get streaming data fairly immediately, is try it out before you even consider some of these boosters.
One of the other ways we improve that reliability is by putting two chips and three microprocessors inside the sensor. So you basically have two LTE signal options. One is called NB-IoT, and the other one is called LTE-M. So we built both those technologies on those two SIM cards.
Mhm.
All right. That was a great answer. Lots of detail there. Next question. In your opinion, what are the key barriers that organizations face when trying to implement predictive maintenance strategies, and how can these obstacles be addressed?
Let me address some of them from a technology point of view, and I would like Limuel to speak at length about this from a
Mhm.
methodology and adoption point of view. From a technology point of view, as I mentioned earlier, look for a program that is not too capex intensive. You shouldn't have to sink hundreds of thousands of dollars in buying hardware, in running wires, in deploying signal antennas and things like that before you start using the asset performance management approach for a small selected few assets. Start with 50, start with 100, start with 20, start with 10, start small. And that way you can feel the program as it begins to scale. So on one side, you're looking for easy to adapt. At the same time, you must look for easy to scale, which means when I want to add more assets, is it too much of work and effort to add, or is it easy to add? Last but not the least, look for a program that not only provides you the advisories and the alerts, but also provides you some actionable information. And last but not the least, you must have access to your data. I hear so many times from customers that they invested in a program, but when they went back to the vendor to get the data from them, they were not able to obtain the detailed, high resolution data to be able to run your own intelligent programs on top of that. So, access to data is another key to look for. At least those three aspects are very important from a technology point of view. Limuel?
Yes. Now, when it comes to determining what type of maintenance strategies, from moving from run to fail all the way to predictive, um, some of the challenges is really the perception of the executives. Without an ROI, as you know, return of investment calculated on the value of failure, that then it's very difficult to sell this type of a program. So the other things that the executives often sees is that they do hear about certain deployment failures from other companies and so on. And what I have seen through the consulting space is oftentimes when a company gets into this type of technology, they go ahead and deploy it in every single asset that they have. And it's the wrong way to proceed. What you will need to do first is determine the critical nature of each of these assets. So you have a priority based asset program and a criticality based program. You deploy these solutions under your critical assets. So when those things fail, it ties into the ROI on what a production gain will cost and what you would gain from it. The other aspect is on the people. Unfortunately, technology oftentimes is deployed without the change management. At the same time, you need to bring the people on board that will be utilizing this type of technology so they understand the different aspects on how to use it and how they can improve their own operations and their own work. So not having the change management program, it becomes more of a behavioral challenge than accepting and creating a champion for these type of programs.
Wow, that was an amazing answer. Thank you, Limuel and Amitabh. Another question. What is your typical blue sensor battery life, assuming it's only measuring vibration and temperature?
Actually, it is measuring way more than just vibration and temperature. Of course, customers can buy it in a tiered fashion. Some machinery, some plant environments are adequate to just monitor vibrations and temperature. But in addition to that, the built in capability inside the sensor includes audio, and we do two audio signals. We take ultrasonic from the surface of the machine, and we take sonic from the environment around the sensor. In fact, this morning, I was talking to a customer that is using our sensor right now for leak detection. They are picking signals in the ultrasonic domain for high pressure leaks, and they're picking signals in the sonic range from relatively low pressure leaks. So we are deploying that in gas fields to detect thief hatch opening or pressure relief valves being purged, etc. In addition to that, we also do humidity measurement when required. This is a software programmable sensor, so you can turn it on or turn it off practically from remote. So battery consumption, that's a great question. The sensor has been built and the program has been designed to give you battery life between 3 to 5 years. And this depends a little bit on how much data is acquired, how often is the data uploaded. Many customers do not know this, that when you are talking about an NB IoT protocol communication, the battery consumption is not so much in the data acquisition. We actually make our sensor wake up every 15 minutes and look at the health of the machine and then take the decision whether the data needs to be uploaded or not. Every 15 minutes, we are sampling it. The battery consumption is primarily when the communication is happening, because that's when the sensor has to establish the connection, dump the data on the cloud, and then sign off from the cloud. So we generally do that once or twice a day based on how often the customer wants the updates to be sent to them. And in that environment, it lasts anywhere from 3 to 5 years.
All right, perfect. And then another sensor question. Are the blue sensors able to form a mesh network among themselves?
The sensors have already been embedded with Bluetooth capability. And the idea of embedding the Bluetooth capability was for them to be able to talk to each other and recognize that they're part of one machine train. So they're monitoring one asset. That capability has not yet been turned on. It depends on how complex the machine train is. For some machines, it makes sense, and for some machines, it doesn't. So, based on every single machine train, we can take that decision. Do they have to behave and collaborate with each other, or can they just upload the data independently? As you turn the Bluetooth capability on, you also have the capability to stream the data onto your cell phone. So, you could be standing on the plant shop floor with your cell phone or an iPad. You could stream real time data from the sensor into your iPad, and now you are using it as a real time vibration analyzer in the field. So, those capabilities are already built into the device. Yes.
All right. And then one more question. How do you approach the training and upskilling of your maintenance team to ensure they can effectively utilize technology-enabled asset management solutions?
So maybe I
I
can
would
answer.
let Limuel answer that. He's an expert at that.
Yeah, we go through a regimented type of program, and there are three approaches that one can take. One is train the trainer, which we would prefer because we do want for a champion within the company to know the technology and how to teach others. The other part, if a company does not have the resources, we do a complete training program from cradle to grave, basically on how to do a maintenance program, how to do predictive analytics, how to assess all these different things. Or it could be a hybrid approach where you may have one or two resources along with our team, and our team will either supplement or be the leader, or could be the programmers within that team. So those three different approaches can be done from a training standpoint. There is formalized training as well as public training that we offer. One thing to make sure that you will understand, you may need to also look at is your resource constraints. We may be able to do the training for a certain resource, but if you don't have the resources to actually use the technology, there are services models that are available for you to consider.
From the adoption of the asset management program perspective, when you deploy a shoreline program, for the first 8 weeks, we get together with you on a weekly basis for an hour, hour and a half to review everything that the platform is doing, all the data that we are acquiring, all the alerts that have come up. And the idea is that during those 8 weeks, we're basically hand holding you how you adopt the program among your own people. For customers that don't have their own reliability staff engineers, we actually do that for the entire duration of the subscription. So,
Mm.
based on how you want us to be involved, LCE and Shoreline together stand behind you during this adoption program for the entire duration. One of the biggest advantages of a subscription based approach is that your supplier, which is LCE and Shoreline, both are committed to your success throughout the life of the program. Because the moment you stop being successful, since you haven't invested in any capital, You can basically say, hey guys, you're not doing a good job for me. I'm done. So, in a subscription based environment, we are highly committed to the success of our customers, our users. And that's how we develop a very customized approach towards build the program, operate it for you for some time, and then hand it over to you for you to run it on your own in the future.
Okay, well, we do have time for just one more question, and it is one more sensor question. So you made a reference that manual data collection was not real time. Do your sensors measure in simultaneous real time for phase comparison, etc.?
Yeah, so, from the perspective of real time, you have to talk about it in relative terms, right? We are going from a monthly or quarterly, or in the best case, weekly route data acquisition. You're going from that. So, one machinery expert is visiting your machinery asset either once a week or once a month, and in some cases, once a quarter when the machines are very remote, like gas production fields. You are going from that to every 15 minutes, an intelligent device that is programmed by software based knowledge from remote. This device wakes up, it looks at the entire spectrum of the signals that are coming from the machine, not just vibration, but acoustics, temperature, humidity. It looks at all those aspects and says, everything seems to be okay, as expected, as per the models that have been built into the cloud. If it says them something is not okay, the sensor is intelligent enough with three computers running inside the sensor, it can then decide, I need to send this data upstairs right now. I need to send it to the cloud. In the cloud, it'll go through the anomaly engine and the customer will receive an advisory within a matter of minutes. So you're right. It's not real time monitoring like a Bentley Nevada system or like an Emerson or an SKF online system. It's not an online protection system, but it is a tremendous upgrade from visiting the machine once a quarter to having an intelligent device looking at your machine every 15 minutes.
Okay. All right. Well, then that concludes the session. If anyone has any more questions, please continue to ask them in the Q&A panel, and we will send all of these questions over to Limuel and Amitabh for them to answer for you later. And thank you again, Limuel and Amitabh, for your wonderful presentation. Is there any last thing that you'd like to add?
I would like to say thank you to the audience for their fantastic questions. And I would like to say thank you, Alexa, to you for your wonderful facilitation, and to my partner, Limuel, for his tremendous contribution to this session.
Oh.
And ditto for me. Thank you, everyone.
Thank you. All righty. So then, thank you for our wonderful attendees today as well. And to thank you, we are going to provide you all with 50% off your conference passes to the CBM and Reliability live training conferences happening in Mexico in August and Australia in November. You can use the code WOW50 and reserve your seat to take advantage of this discount. These events will include certification training opportunities, hands-on workshops, and case study sessions. Visit MobiusConnectConference.com to learn more about these live and in-person events. And you can also find the link to register in the follow-up email after this webinar. Speaking of that follow-up email, please look out for that, because that's where you will find the on-demand version of this webinar and your certificate of attendance. And coming up next, we have new technology wireless solutions using LTE-M, including customer case Sagadraca, Sweden by Hakan Hedlund. This will be Thursday, July 27th from 7 to 8 a.m. Eastern Time. So if you haven't signed up but want to attend, please go to your attendee hub and click join now when the session begins. And if anyone's interested in engaging with other industry professionals or would like to participate on the industry's live feed and forums, you can visit MobiusConnect.com, create a free profile. Also, be sure to follow us on social media at Mobius Connect to stay up to date with the latest community happenings. Now, if you have any questions, please don't hesitate to email the Mobius Connect team at info@mobiusconnect.com. Thanks for joining us, everyone. Have a great day. Please stay safe, and we'll see you next time. Bye.